All right, so we're going to look at the first page of the test review. Find the area of the triangle. Now remember the formula for that is A equals 1/2 the base times the height. And remember that the base and the height are always perpendicular to each other. So here's my base, and this is my height. So I'm going to go ahead and write 1/2 times 40 times 18, and 1/2 of 40 is 20, so 20 times 18, that's just going to give me 360. So since we're dealing with area, remember we're going to square our unit, so this is going to be 360 square centimeters. For number 2, it says find the area of the kite, so that's just going to be A equals 1/2 times diagonal 1 times diagonal 2. So all of this is multiplying, so we have 1/2 of our first diagonal, which is going to be 17. So 1/2 times 17 times 21. So I can go ahead and put this all into my calculator. I can do 0.5 times 17 times 21, and that is going to give you a decimal. So it is 178.5 exactly, and our unit will be meters squared. Number 3, find the area of the trapezoid. So your formula for this one is A equals 1/2 of the first base plus the second base multiplied by the height. So these are our two bases, and this is our height. So then we're going to go ahead and input 1/2 times the first base is 16 plus the second base is 6 multiplied by the height, which is 12. So then I have 1/2 of 22 times 12. 1/2 of 22 is 11. 11 times 12, that's 132. So 132 square feet. Number 4 says find the area of the rhombus given the following half diagonals. So the diagonals are going to bisect each other at a midpoint, and this applies to a rhombus. So if this bisects this and this bisects that, we're going to have a midpoint. And what's going to happen for this particular segment, it's going to split the segment into two congruent parts. So we know that this segment is congruent to this segment, and this segment is congruent to that segment. So if this segment in particular is 6, then we know for sure that this is 6 as well, right? And then if this is 4, then this is also 4. So this is also 4. So what do we have? We have our first diagonal. This here will be 8 units long, so 8. And then right here, that's just going to be 12 units long. So using my formula A equals 1/2 D1 D2, I have 1/2 times 8 times 12, and 1/2 of 8 is 4. 4 times 12, that's 48. So 48. And what's the unit? Well, it doesn't specify, so we're going to go ahead and put 48 units squared, or you can say 48 u squared, okay? All right, so now we're going to go ahead and look at number 5. Find the area of the triangle. Leave your answer in simplified radical form, which means we need to keep it exact. We should not have a decimal. So here's the thing about this triangle. Anytime I see an equilateral triangle, meaning all the sides are congruent, I can find the area using this formula. So I can write A equals S squared root 3 all over 4, where S represents the side. So we know that the side, or one of the sides here, is 8. So I can go ahead and say 8 squared root 3 all over 4, which becomes 64 root 3 over 4, okay? So now, look, I can cover up this root 3 and pay attention to the 64 divided by 4. 64 divided by 4 is 16, and then we slap on that root 3. So your answer is 16 times the square root of 3 centimeters squared. Okay, so that is how you keep it exact. You can use Heron's formula, but you have to simplify the radical. I think this is good enough where we just use this formula and then get straight to the answer. Using Harans on this one is going to take you a bit, so I wouldn't recommend doing that. Now let's take a look at number 6. It says find the area of the regular polygon given the center point. So here we have a parallelogram and it's a regular polygon. So this implies that we're dealing with a square. Okay? So the area of the square formula is just A equals S squared, or A equals side squared. Now notice that what we have here is this little segment from the center to one of the vertices here, and that's 9 inches long. But we don't have a side length. So what are we going to do? We're going to go ahead and create another segment from the center to one of the vertices right here. Okay? So we know with the square, this angle is 90 degrees. This is 90. This is 90. And this is 90. But if I drew in that segment, it's going to split the 90 into 2 congruent parts, right? So we have 45 here, and this is also 45. And if that's 45, we know for sure that this is 45, right? And look, we have a triangle. So 45, 45, that means that this angle here, is going to be 90 degrees. So you're dealing with the special right triangle. So if it's across from 45 degrees, then this side here is 9, this side here is 9, and then across from the 90 degrees, across from the 90 degrees, this is going to be 9 times the square root of 2. So that is your side length. So I can go ahead and replace the S with 9 root 2. So 9 root 2 quantity squared is equal to 9 root 2 times 9 root 2. And remember, we multiply the coefficient to the coefficient and the radicand to the radicand. So we have 9 times 9, which is 81. And then we have the square root of 2 times the square root of 2, which is the square root of 4. The square root of 4 is just 2. So remember, the square root of 2 times the square root of 2 is 2. Any radical multiplied by itself is just what's under the radical. Okay, so 81 times 2 is going to give you 162. Don't forget the units here. So 162 square inches is your answer for number 6. Okay. All right, so moving on to number 7 here. It says, given circle G, which means that the center point is G, find the sector area. Leave your answer in terms of pi and as a simplified fraction. So remember, the formula is A equals x over 360 multiplied by the area of the circle form, which is pi r squared. So what's the radius? Well, the radius is always from the center to the circle, which is 12, right? So r is equal to 12. And the shaded region is 133 degrees. So I can go ahead and replace x with 133. So 133 over 360 times pi 12 squared, which simplifies to 130 over 360 times 144 pi. But I'm not done yet because I need to simplify this even further, right? So I'm going to use my calculator, and I'm going to input 133 divided by 360, multiply that by 144, then I'm going to change that decimal into a simplified fraction, which I'm just going to press math, enter, enter. So your answer for number 7 is 266 pi over 5. Or you can just say 266 over 5 and then write the pi right next to it, right next to the fraction that is, and that's totally fine. Don't forget the units. That's just going to be 266 pi over 5 feet squared. All right, so that's just your answer. That is your answer for number 7. Number 8, it says find the area of the triangle. So the triangle being the shaded figure. This is not going to be part of our answer, but that's just going to support us when we need to find a missing side length, if that makes sense. So the area of the triangle form, really, really simple. A is equal to 1/2 base times the height, where the base and the height will always be perpendicular to each other, right? So here's my base, that's 29, and perpendicular to that is this little segment here. What is that segment? Well, we know, just based on this little triangle here, it's a right triangle with side length 6 and the hypotenuse is 10. So if you remember your Pythagorean triples, then you know for sure that this side length here is 8. But I'm just going to go ahead and just use the Pythagorean theorem to figure out what that missing side length is anyway. So a squared plus b squared equals c squared. Now, we know that one of the side lengths is 6, right? It's one of the legs. So I write 6 squared plus, do I put 10 for b? Well, remember, this is across from the 90-degree angle, so that is actually our hypotenuse. B is what we're trying to figure out, right? So 6 squared plus b squared equals 10 squared. And then I'm going to go ahead and subtract both sides by 6 squared here. So I have b squared equals 10 squared minus 6 squared, take the square root on both sides. So b is equal to, if you input all this into your calculator, you're going to get 8. So this little side here is 8. So I'm going to go ahead and find the area now. Remember, the base and the height will always be perpendicular to each other. So it's 1/2 times the base, which is 29, multiplied by the height, which is 8. And I can go ahead and just say, oh, 1/2 times 8, or 1/2 of 8 is 4. 4 times 29. That is going to give you 116 square centimeters. Okay? Let's take a look at number 9. Find the area of the regular polygon. So whenever we're trying to figure out the area of a regular polygon, it is A equals 1/2 times the apothem multiplied by the perimeter. Now the apothem will always be from the center perpendicular to one of the sides of our regular polygon. So in this case, our apothem here is 4 times the square root of 3. And then the perimeter is just basically, you're adding all the sides, right? So we only know that this side length here is 6, but since we have a regular polygon, which means all sides are congruent, all angles are congruent, then that implies that all the side lengths for a regular polygon is 6 each, right? So 6 centimeters, 6, 6, 6, 6, and 6. And we have 1, 2, 3, 4, 5, 6. That's a hexagon, so I can do 6 times 6 to figure out the perimeter, which is 36, right? So I can go ahead and just replace. I have 1/2 times 4 root 3 times the perimeter, which is 36. So I can just simply say 1/2 of 4 is 2, so I have 2 root 3 times 36. And I can only multiply the coefficient to the coefficient, okay? We can pretend that there's a square root of 1, but I don't want to get into that territory where I have to explain further than that. All I want you to know is we're going to multiply the 2 and the 36 together. Do not multiply it with the square root of 3 and make it look like it's 36 times 3. Don't do that. You're going to slap on the square root of 3 at the end, okay? So 32 times 6, that's just going to be 72. Then you slap on the root 3, and that is going to be your answer. But don't forget, we always want to include our units, so that will be centimeters squared, okay? So that'll be number 9. Number 10, find the area of the triangle with side lengths 10 meters, 17 meters, and 13 meters. Round to the nearest tenth. So for this problem, we do not have the height. Now, if we do not have the height, we're going to apply Heron's formula. The first thing that you have to do is always find your semi-perimeter, which means that you add up all the sides. So S is equal to 10 plus 17 plus 13, and then you divide the result by 2. So 10 plus 17, or actually I can do this. 17 plus 13 is 30 plus 10, that's 40. So I have 40 divided by 2, which is 20. So the semi-perimeter is 20. So now what we're going to do is we're going to use that formula, which we're going to give you on the day of the test, right? So A is equal to the square root of the semi-perimeter times the quantity of the semi-perimeter minus the first side length times the semi-perimeter minus the second side length. And then lastly, the semi-perimeter, right? You're multiplying semi-perimeter minus the third side length, which is 13, but that is our B value, right? Oh, no, not B, C value. All right, so let's go ahead and call this A, B, C. We know the semi-perimeter, that's 20. So I have the square root of 20 times the quantity of 20 minus 10 times the quantity of 20 minus 17 times the quantity of 20 minus 13. So what I'm going to do is I'm going to put all of this into my calculator. Oops, wrong one. Wrong app. All right, so I have second x squared 20 times the quantity of 20 minus 10 times the quantity of 20 minus 17 times the quantity of 20 minus 13, and that is going to give you approximately, so we're rounding to the nearest tenth. I'm looking at that 0. It's not going to change that 8 whatsoever, so we're going to have 64.8 square meters, right? We need a square unit because we're still finding the area. So that is our first page of the Unit 11 test review.